Unit 4. Areas. Contents. Equality of areas of two parallelograms. Equality of areas of two triangles. Areas of some geometrical figures. First exercise on the unit. Second exercise. Third exercise and fourth exercise. Lesson 1. Equality of areas of two parallelograms. If a straight line intersects with two parallel lines, then number 1. Every two alternative angles are equal in measure. Number 2. Every two corresponding angles are equal in measure. Number 3. Every two interior angles at one side from the transversal are supplementary. The parallelogram. Let ABCD is a parallelogram. Then, number 1, AB equals DC and AD equals BC. Number 2, AM equals MC and BM equals MD. Number 3, the measure of angle A equals the measure of angle C, and the measure of angle B equals the measure of angle D. Number 4, the measure of angle A plus the measure of angle B equals the measure of angle D plus the measure of angle C equals 180 degrees. Also, the measure of angle B plus the measure of angle C equals 180 degrees. The height of the parallelogram. In the opposite figure, AE is the height corresponding to the base BC, and AO is the height corresponding to the base DC. Note: for ABCD parallelogram, XY line segment, DE line segment, AO line segment, and LM line segment are considered as heights of the parallelogram corresponding to the base BC. DE equals AO equals LM equals XY. The relation between surfaces of two parallelograms. Theorem 1. The two parallelograms which have the same base included between two parallel straight lines, one of them carried this base are equal in area. Given ABCD and HBCO are two parallelograms. BC is their common base. BC straight line is parallel to AO straight line. Required to prove. Prove that surface area of the parallelogram ABCD equals to the surface area of the parallelogram HBCO. Proof. Since the triangle DCO is the image of the triangle ABH by translation, whose magnitude is BC in direction of BC ray. Therefore, triangle DCO is congruent to the triangle ABE. Therefore, surface area of ABCO minus surface area of the triangle BCO equals surface area of ABCO minus surface area of triangle ABH. Therefore, surface area of parallelogram ABCD equals surface area of parallelogram HBCO. Corollary number 1. The parallelogram and the rectangle that lies between two parallel lines and having a common base are equal in area. In the opposite figure, the surface area of the parallelogram ABCD equals the surface area of the parallelogram BCHO. The surface area of rectangle equals length times width. The surface area of parallelogram equals base times height. Corollary number 2. In the opposite figure, surface area of parallelogram equals length of base times height, and surface area of ABCD equals base times height. Surface area of parallelogram equals length of base times height. Then, surface area of ABCD equals BC times DO. Example, parallelogram, its base length equals 10 cm, its height equals 6 cm. Find its surface area. Solution. The surface area equals 10 times 6 equals 60 centimeters squared. Example. In the opposite figure, ABCD is a parallelogram. AB equals 8 cm. AD equals 12 cm. The measure of the angle ABC equals 150. And AX straight line is perpendicular to BC straight line. And DY straight line is perpendicular to BC straight line. Find number 1, surface area of AXYD. Number 2, surface area of ABCD. Solution. Since the measure of the angle ABC equals 150 degrees, therefore, the measure of angle ABX equals 30. In triangle AXB, AX equals half AB, equals 4 cm. Surface area of ABYD equals length times width, equals 4 times 12, equals 48 centimeters squared. Surface area of ABCD equals surface area of AXYD equals 48 centimeters squared. In the opposite figure, ABCD and ANOE are two parallelograms. Prove that surface area of ABCD equals surface area of NAEO. Solution. Area of ADE equals half area of NAEO, having BC common base. And area of ADE equals half area of ABCD, having AD common base. Therefore, area of NAEO equals area of ABCD.